Okay, so you see your schedule for today. We will do our homework that was on scientific notation, exponents, radicals, and probability. And hopefully we'll get to combinations. That's a new topic.
I'm frustrated. Yeah, you see.
What's the matter?
I said that he got me so frustrated.
What?
I said, can I take this heat?
Oh, this heat. Yes, I understand
I had
that.
to postpone the appointment day before, but I go to the other one tomorrow, so it kept on frozen.
Oh, okay. All right. Let's go to. Oh boy, I hope I can find my.
I could just like it.
Yeah, there we go. Let's see if I can get this up. Okay, new share. Here we go. All right, now, do you see the homework?
Yeah.
Just the topic. No, I see.
You see it? Scientific notation, rationalizing, radicals,
Yes.
and probability practice homework, 721, right?
Yeah.
Okay, now the first one was true or false questions. And Maureen, you had them all right, but one. Okay, let's find out why you missed that one. Okay, Maureen, go through the true or false. Tell me the answer and why you selected it.
Okay. We'll see.
Read number one.
Probability.
Should I make it bigger, Maureen?
If the girl can't see, but I can see.
Okay. Let me make it bigger. Mercedes, can you see it? I make
Yes,
it
I can
bigger.
see it. I can.
Okay. All right. Go ahead, Maureen.
The probability is a chance of something happening.
True or false?
True.
That is true. So you put in true. Number one is true. Mercedes, question?
I agree.
Okay. All right. Go to number two, Maureen.
Here's number two. Oh yeah. A probability can only be measured as a decimal.
True or false?
False.
Because probability can be measured as a decimal and what else?
I know, but I know it for sure.
Well, what else, Mercedes? Mercedes knows. What else, Mercedes? Decimal and what else?
Decimal and fraction.
Fraction, yes, and what else? Percent.
Percentage. What
right. They go together, right? Decimal, fraction, percent, and also ratios. All right.
Yes.
So two is false. So let's just put number two is false. All right, Maureen, number three.
Experimental probabilities is when you actually try something to see what the outcome will be.
True or false? That's true. Yeah, we had that with something when I gave you that table, remember? But then I asked you for a theoretical probability. Okay, Maureen, number four.
Theoretical probability is
theoretical.
Theoretical probability is used to predict if something is likely to happen. True.
That is true. So you put true. All right. Now the very last one, Maureen. Read the last one. Let me.
Probability can be more than 100%. And I had true, but it's false.
It's false. That's right. 100% is max. So if you use a percent, it's 100. If you're using like a number, it's 1. What does the probability of 0 mean, Mercedes? So number 5 is false. Let's put it here. Mercedes, what does the probability of 0 mean, Mercedes?
I don't remember. I'm sorry. It's a shame.
You know, Maureen, what a 0 probability means?
No.
Can't happen. That's all.
Oh,
Probability of 0, it can't happen.
I'm
You know,
thinking
I should have really
the
get
one.
that right in Miss Bible.
Yeah.
I know you should have gotten that right,
Be-
Maureen.
be-
That's why I had you
be-
go through it.
Because I had false, and then it turned around against the truth. I changed
Yeah,
it, yeah.
I'm sure, I thought you did. That's why I wanted you to go through it, because I said now when you go through it now, you'll have the right answer, right? When you say can only be measured as a decimal, well, you know, fractions, okay. Can it be more than 100%? No, that's the highest it could be, 100%. Or if you're using the numbers, 1, okay, can't be more than 1. But if it's 0, that means it can't happen. In other words, you can't get heads and tails at the same time, right?
Yeah.
Yeah.
Probability of heads and tails on one throw of a coin is 0, because you can't, that's impossible.
Yeah.
All right.
Mm.
Okay, so that was 1 through 5. And Maureen had 4 of those correct. She really had 5. She just changed her mind on it. See, when she did it now, she had it correct. All right, let's go to number 6, Mercedes. Read number 6 and tell me what you think the answer is. Okay, let me make this bigger. Read number 6, Mercedes.
There are 2 red and 3 blue marbles in a bag. What is the probability of drawing 2 red marbles from the bag with no placement? Well, I choose B.
You choose B
Yeah,
as in boy.
Yeah.
Why?
because it is five marbles in all total, red and blue total. And if it oh no, I'm wrong.
So
C,
what's the answer?
C,
What?
C.
As
No,
in,
A. Finally, A.
so that's your last answer.
Yeah. Am I
Now,
wrong?
why did you choose A? Now I want to know why you chose it.
I look at it now and I says, oh, if it's 5 marble, let me see. What is the probability of drawing 2 red marbles?
See, 2 red. So there's just 2 red. Let's underline that. That's what you're trying to determine. And you have 2 red and 3 blue. Okay.
That's fine.
So, okay. What's the probability of 1 red? Mercedes.
Okay, we'll say A then. Because 1 from 5 leave 4, right? So that's why I choose B in the first place, because I said if you get probably take out 2 red, they're gonna leave 3 blue.
Okay, let's do it this way, Mercedes. What's the probability of getting a red marble? What's the probability of red?
1 to 5.
1 to 5. Very good. All right. Now, so if you've got 1 to 5 for 1 red, what's the probability of 2 reds?
2 to 5.
No.
What?
Remember, when you have 2 events here, you find the first one and then you multiply. This is a product.
So that'd be like 10.
So what would it be? What would it be, Maureen?
10.
No, not 10. The probability of a red is 1 over 5. So the probability of 2 reds would be 1 over
1
5
over 10.
times 1
Times
over
1
5.
over
And that's
5, right.
equal to 1 over 10.
Up to 10, yeah.
Okay, that's 1 over 5 times 1 over 5. And what's that equal to, Mercedes? 1/5 times 1/5 equal what?
10.
No, 1/5 over 1/5 is not 10. 1/5 times
1/10.
1/5 is equal to what, Mercedes? Multiply numerator, multiply, then, I'm sorry. One, this is not this is a add, not a product.
Right?
Because 1/5 times 1/5 is 1/25. So what's 1/5?
1/4.
No, wait a minute. Okay, so we have one red over, it's 1/5. And we have one, no, 1/5. No, 1/5 plus 1/5 is really 2/5. But this is a multiplication. I don't think I have the answer here. Because 1/5 times 1/5 is 1/25, 1/25.
That's what I said.
Well, but I'm saying I don't have that answer there. So I think I may not have put the answer here. So the probability of one red is 1/5.
This is a quarter.
Let's see, 2/5, 2 times 2 is 4. And 5 times 5 is 25. No. No, the probability of one red would just be really 2/5. Okay, here's the problem. Once you take a red out, you only have
One red left.
one red left. So this would be, okay, if it's probability of a red, let's see, if that was 2/5. So when you get to the other red, you don't really have 5 left, you have 4.
Or
So that would be 1, let's see, 1/4. I'm sorry, so that would be 1/4. And then you multiply. And that would be 2/20 or 1/10. Okay, I know the answer is 1/10, but here's how you get it. Okay. Okay, so the probability of one red, the probability of the second, and I'll just put the second red. So first red is 2/5, right? The second red will be 1/4 because we've taken out a red and we only have 4 total left. Now you do your multiplication. The probability of 2 reds, one after the other, would be the product of 2/5 times 1/4. And what's that equal to, Mercedes?
that is over 5 times.
That would be 2 times 1 is 2, and 5 times 4 is 20, and 2/20 equal 1/10. That's how you get the 1/10. Answer D. Remember when we said when you replace, that's like a dependent event, because
Yeah.
without replacement is a dependent. So that means your total goes down. So your first probability is the number of reds over the total, 2/5. The second red, you've taken a red out, that would be 1 red left and 4 total left. And then the probability of the 2 reds would be the probability of 1 red times the second red, and that's 2/20, 1/10, which would be answer D. Questions on? I think we did that with the when we had the bag with the colors, with the color towels in it. You remember when it was a dependent event? And when you remember, I said when you say with no replacement, your
Yeah.
total is decreased. So if it was 5 in the beginning, it's 4 now. So 2 over 5 when we started. The second red, we've taken a red out. So we have 1 red left, total of 4. And this is the product rule. So you multiply the first red probability times the second red probability.
Uh-huh.
And you get 1 over 10, your answer. Questions?
But I'm not so clear on that. Eventually I will.
Okay. Mercedes, remember when we did the tiles and we said we took, I think, some colored tiles out and we said, what's the probability of the first one? Then we had a column, the probability of the second one. But remember when we said no replacement, that means your total is decreased by what you took out.
Okay.
Yeah, I remember that.
You follow? See, there's a total of 2 reds, 3 blue. That's 5, right? But if we take a red out, how many do we have left, Mercedes?
1 red.
Total.
Sorry, I mean the total, if you take 1 out of the 5, it would be 4 left.
Yeah, that's why we have a 4 here. So we've taken out a red, so now there's just 1 red left.
Yeah.
So the probability of get that second red is the number of reds, the possible, that's the 1, total is 4. All right. So whenever you have 2 events, you find the probability of the first event, probability of the second event, and then multiply them.
Oh.
So this is the first event, the first red, 2 out of 5, 2 reds out of total, 2 red plus 3 blue gives you 5. Second red, I've taken a red out, so I only have 1 red left, right?
Yeah.
And now my total is 4 because I took a red out. So my total decreased by 1. So
Okay.
probability of the first is 2 over 5. Probability of the second, 1 over 4. The probability of the 2 reds is the 1 red times the probability of the 2 reds. The second red. 2 over 20, and then simplify it to 1 over 10.
You hear the president got the virus?
What?
Yeah, President Biden got COVID-19. He tested this morning.
Oh my goodness, I didn't know that.
Yeah, yeah. He said
Yep.
he got it this morning. But
Well, you know, with the new strand, people are getting it even if they've had the shots and the booster.
But the second is mild. And he's still in office doing the work, but he isolated.
Oh yeah, but that's right. He can't be around people. Okay.
Who got it?
The president.
Oh, no.
I'm not surprised. I mean, a lot of people are getting it who really had the shots because there's more than one strand of it. So that's what's going on.
Not that alone. He visit so much different countries.
Oh yeah.
And yeah, talking about
yeah. So the people that he's been with and the people around him here in the US, his relatives too, his wife. Yeah, because they all have to be tested.
Yeah.
Because they were exposed, right?
Exactly.
Okay, number 7, Maureen. What's the answer? Tell me 7. Read it. And Mercedes, did I answer your question on number 6?
Yes, thank you.
Okay, just remember whenever you have 2 events, you have to do both events and then you multiply them. All right, that's the key.
Okay.
And if it says no replacement, your total is going to change, right?
Yes.
That's what makes it a dependent event. Yes.
Before Maureen do that one, I looked at it though, but I said I didn't understand how to do it.
Okay, Maureen will explain it to you.
I came home late this morning to
okay. Maureen, read number 7 and tell Mercedes how to do it.
Harry was interested in a lottery draw and compiles a table of winning numbers that include 1, 5, 12, and 22. Assuming that there are 49 possible numbers in the set to be drawn, what are your chances of drawing 1 in your first draw?
Okay, so
So
here's your key right here.
yeah,
49 possible numbers.
yeah. So if you draw one, it'd be 1 in 49.
That's right. 1
What's
in
that?
49. That's the answer.
1 in 49.
What's that again? I don't get it. Um,
Explain how you got that, Maureen.
They,
Explain
they
that.
give they give these numbers top right like 1, 5, 12, and 22, but they're really talking about those numbers. They're talking
what?
that assuming that there are 49 possible numbers in the set to be drawn. What are your chances of drawing one in your first draw? So it'd be 1 over 49.
Yeah, in other words, what Maureen is saying, Mercedes, these numbers they gave you, that's like work you don't need in the problem.
Oh,
Okay, see, they compiled a table of winning numbers and they included these numbers, but that has nothing to do with the probability. Probability is possible over total. So it's just like you pull a card out of a deck of cards. What's your probability of getting a two? 2 over 52, right? A
okay.
1 over 26.
You said
Okay.
you said assuming that there are 49 possible numbers
Mm-hmm.
set to be drawn. What are the chances of drawing a one in your first draw? Oh,
So what is probability? Possible. That's your one. Drawing a one is the possible, right?
because I see those five, 1, 5, 12,
Yeah,
20.
that's
That is
called
not
a red
included. That is
herring.
not included.
That's called a red herring. That does not factor
That's
into
yeah.
your probability.
Oh,
The fact that Harry made a table of winning numbers that include these numbers does not affect your probability.
okay.
He just made up a table of winning numbers, right? It's just like if if,
49.
if someone wrote down um, like a deck of cards has 52 cards, right? And somebody wrote down, I got a queen, I got a 5, I got a 6, I got a 9, and I got a 10. And then you say, what's the probability of me getting a 7 if I draw a card out of my deck? It's still going to be 1 over 52
Okay.
because they're total possible over total. Possible is what you're getting, and total is how many cards in the deck, 52. You
Oh,
got
so
it,
the
Maureen?
focus is on the 49.
Yes, 49 possible numbers, right? So that's your total. So the probability of getting a 1 in your first draw is 1 in 49. Just like if it says, what's your chances of drawing a 9 in your first draw? It would still be 1 in 49. You got it?
Yes.
Possible over
Thank-
total. Okay. All right. Look at number 8. Maureen, I
I
think
got that wrong.
you had that one wrong. Now
Yeah.
Mercedes can probably get it, right? Mercedes, read number 8 and tell me the answer. Let me make it bigger. And you tell me what is the answer for number 8.
Let's see.
I do open my
Read number 8 and tell me the answer.
Let me see if I understand. Which following is an outcome? Which of the following is an outcome? Rolling a pair of dice. A. Choosing 3 marbles from a jar. B. Winning a prize in a raffle. C. Or none of the above.
Which one would you say is an outcome?
Um, A.
No.
Wait. Rolling a pair of dice. Choosing a 3 pair. An outcome. Okay, I choose C then.
C, that's right. The outcome is what occurs after the action.
I had to see it on. I changed it.
What did you have, Maureen?
I had to see, but I changed it to D.
I know you. Yeah, I know. But I
No,
said that looks like something Maureen changed.
Okay.
Okay. Answer. And that's what Mercedes said. That's the outcome. The outcome of playing the raffle is winning a prize, right?
If I didn't change that too, I would have only got one wrong. That was number 6. But I changed it too. Yeah.
I know. Yeah. So Mercedes has that one right. See, these are events. Now, if I said, now you roll a pair of dice, right? If I said getting a 4 on a roll on rolling a pair of dice, that would be an outcome, right? But actually rolling a pair of dice, that's just an event. This is what occurs after you played buy a raffle ticket. Buy a raffle ticket, event, winning a prize, outcome of buying the raffle. You got it?
yeah.
Okay, so that's C. Okay, Maureen, number 9. Which scientific notation? What did you choose? I think you had this one right. You had that one right.
Yeah.
Okay. All right. And why did you choose A?
No, I don't remember left and right, but I think I went left, right? I don't remember left from
Your
right.
decimal point is behind this 8, right? And
Yeah.
you went to the left how many places?
5 places.
5, and put it between the 8 and the
And the
3
3, yeah.
right here.
Yeah.
And since you move 5 places, your power would be 5. Mercedes, did you get A?
Yes, because I was looking at C.
Okay, so you should.
But I said there is not C. A.
Okay, but you moved the decimal point to the right place, right?
Yes.
Okay, so that's answer A. Okay. All right, let's go to number 10. Okay, Mercedes, number 10. Tell me the answer and why. Make it bigger. What's the answer to number 10?
The answer for number 10 is D. Sorry. C.
C, that's right. Very good. Why is it C, Mercedes?
What is the negative what do you call it now? The answer is that when there is no zero, there's
Well,
all it says is a zero.
yeah, you could put a 0 here, right? But there's no 0, but you don't see a number greater than 0, right? So you could put a 0 there, or because that's the default, right?
Yeah.
Okay, but if you don't put it there, you still don't see a number greater than 0 here. So you know it has to be a negative exponent, right?
Yeah.
And where did you move the decimal point? Between what?
Between 2 and 5.
That's right. Between 2 and 5 would give you a number between 1 and 10. That's 2.5. And you know it's negative, and you moved it how many places?
We move it 3 places.
3 places. That's right. 1, 2, 3.
Yeah,
Answer C. Maureen, you had that one, right?
I had that one wrong, but I do it.
Okay. Now, Maureen had this one right, but Mercedes, I want to see if you can get 11 correct. Now, let me just put it on the next. Okay. Now, you're looking for equivalence here, right?
Oh, where are you? Okay, I see it now.
Number 11. Which of the following is equivalent to 5637.82163 times 10 to the third?
Oh.
Which one would you say? I'll say these and why.
I would say just
Which one? A, B, C, or D?
1 second. Let's look at this number. Okay. All right. I should know.
Remember this number in front of the 10 to the third, that part of our scientific notation. If that's decrease, the exponent increase. If this increase, the exponent decreases. So knowing that, which answer would you choose and why?
I would choose B.
You would choose B. Why?
Because if you have if you have the point between 1 and 6,
5 and 6, you have it here.
or 5 and 6, sorry.
Uh-huh.
You have the number, it's less than 10. It's less than 10. I'm not sure.
But is that okay, the decimal point is here, Mercedes. If you move it between the 5 and 6, is that an increase or a decrease?
If I move it to the left towards,
If you move it between the 5 and the 6, and it's sitting right here after the 7, in other words, 5,637. So if you move it between the 5 and the 6, is that an increase of that number or a decrease?
increase.
5.63 is bigger than 5,637?
Ask me the question again, Miss.
No, your decimal point is here behind the 7.
Yes.
In B, it's between 5 and the 6. The number that you got from moving the decimal point between the 5 and 6, from where it is right here, is that an increase or a decrease?
For the power, I would say it's a decrease.
I'm sorry, you said it's what?
For the power, it will decrease.
No, I'm not talking a power now. I'm talking just a number. Okay, let me put it here. 5637. 5637. So let me just write that here. What I'm asking you, if you go from 5637 to 5.637. My question for you, was that an increase or a decrease?
I would say an increase.
So you're saying 5.637 is bigger than 5,637?
Okay.
2.
It's-
Okay. You said it. Now I ask you again, Mercedes. 5637. That's where you see it right here. And say if you go to 5.637, is that an increase of this number or a decrease?
It's a decrease.
It's a decrease, right? And if it's a decrease, what happens to the power?
The power going to increase.
So, but this power 10 to the third is the same as this one. So it can't be B. I just wanted to see why it can't be B, because B has the same power. So if you change in this number, then the power has to change. So B, it can definitely not be. Right?
Okay.
So you eliminated B, because if it has the same power as it does right here, then this number can't be this.
So the answer is C? No, A?
Now, now,
Am I mixing up?
now A,
Increase, I mean, increase. So
okay.
if you increase, the answer should be C. Am I wrong again?
Why is it C?
Because yeah, no, it can't be C because C would be -3 because it decreased. So the answer should be B.
No, B is 10 to the third. It can't be 10 to the third, Mercedes, because if it was 10 to the third, this number would be, it can't be this, this 5,637.82163 times 10 to the third. You can eliminate something times 10 to the third because the number here is not the same as this number. It's not the same as this number right here. These set of numbers, actually.
That's what number is a little tricky for me. So I'm sort of buffing between two.
Mercedes, let Maureen help you out. Maureen, what's the answer and why?
I know the answer, but I can't figure out why. But I know I could have figured out the sound without thinking.
So what's the answer, Maureen?
D.
What?
D.
As in what?
Now,
Dog. And why is it D, Maureen? Why is it D?
I can't know why.
I know it was D because
Negative.
okay. Because there are like there's 4 different sets of numbers there, right? There's 5.6, 5.6, and then one is 56. So I figure that I don't know, no, that 5637 is straight number. If you move the decimal point, and then it comes like a decrease. I don't know. That's how I figure it out.
Yeah, you're right. Because, well, say why it can't be C. The reason it can't be C is why? Because if you decrease the number, you have to increase the power. But from a 3 to a -3 is a decrease of power, right?
Okay.
Okay. If you decrease the number, the power should increase. But if you look at D, D is increasing by what? You're going from this decimal point to behind the 3. How many places is that? 5, right?
Yeah.
So you increase by 5, you have to decrease your exponent by 5, right? So what's a 3 and a -5?
That's the one.
+3 and a -5. Because see, when you moved it here, that's 5 places, right? So you increase it by 5, you've got to decrease your power by 5. So that would be what? -5 +3. And what's that equal to, Mouse ladies?
-2.
-2. That's why D is correct.
Okay.
This is -2.
I understand when I see the double with the point in the middle.
Yeah. See, you got a decimal point here, but when you look at D, that decimal point is moved behind this 3, right? But how many places you moved it? 1, 2, 3, 4, 5. So if you increase this by 5, you've got to decrease your power by 5. That's the -5 +3. Your power is a -2.
So forgot about the 10. Oh, the 10 had nothing to do, just 2.
Well, the 10 is to a power.
Yeah. Okay.
All right. So, but I'm saying you could eliminate, well, you can eliminate this first one because the first one you're doing a decrease, so your power should increase. right?
Okay.
If you were decreasing this, then the power would increase. Okay, and this one, of course, this is 10 to the third, can't be this one because this is 10 to the third. So, and this is not saying 5637, it's saying 5.637. All right,
Okay.
and this one is a decrease. We go to here, so your power should increase. That power is decreasing. The last one is an increase of the number in front of the times 10 to a power. So if it increase, then decrease the power. You move 5 places, the increase, you subtract the 5 from the 3 to get the power. So that's like adding a -5 to a 3, so your power becomes -2. Now, Maureen got hers based on elimination, right, Maureen?
Yeah.
You just eliminated A, B, C, and said it's got to be D. Questions, Mercedes?
No, thank you, Miss.
Okay. Now, just remember that sometimes you have to do this in order to do operations on your numbers. Because remember, I said you can't add or subtract powers unless the powers are the same. So sometimes you have to do this.
Okay.
All right, that's why we went through it. Okay, let's go to number 12. Now, number 12, you were given scientific notation and you were to make it what? Standard. Mercedes, what's the answer and why?
I'm just looked up. Okay. So write the following number in standard notation.
Okay. And it's scientific notation, right?
So, oh, so the answer would be A, because
Why A?
because you have the point between 3 and 8, which is 3 is less than 10.
But what
Uh,
about the 10 to the -4?
oh,
10 to
oh,
the -4, remember, it's going to be 0
oh,
point
oh, oh,
something, right? Remember,
yes.
I told you how you can tell if you have a number in standard and it's a negative exponent, then your standard is going to be 0 point something. So you can eliminate A and C. Got to
Oh,
be B or D. Which one?
okay, the answer is D.
How many places do you move the decimal point in D?
Holy Moses. All right.
Decimal point is here. If you put
Oh,
it here, how many places is that, Mercedes?
that's 3 point places.
That's 3 places. So the answer is what?
B.
B.
I see.
Answer B.
Miss,
Go ahead.
I understand what you did with it. You up there, you have 3.809 times the 10 to the fourth negative fourth power.
Right.
Fool me because there is no, it's not a zero, it's a 3. So if it is a 0, I catch on with the negative.
Yeah.
So it's so clear
What's not so clear?
because you have, instead of a 0, you have a 3.809 times to the 10's -4. So that's why I'm looking. Oh, when I see -4, then I should look down there to say that, get look for the answer would begin with 0 point. Oh,
That's right.
got
That's
it. Got
right.
it.
So you can eliminate A and C.
And I get an interrelated, which says 4 is negative 4, so I have to count the place.
Yeah, and if you didn't have a 0 here and you said point something, just the 0 is the default.
Okay.
Okay, so that means you can eliminate A and C because those would be positive powers, right?
Yes.
3.809 times 10 to the 1, and this one would be 3.809 times 10 to the third. These would have positive powers, A and C. So only B and D will have negative powers, right? Because when you move to the right, you know you got negative. Move to the right, negative. D is moving 3 places, but B is moving 4 places, and that's equivalent to your -4 power.
Okay.
Got it?
Business solver.
Okay. Now let's do rationalizing. Okay, Mercedes, I want you to do this one. Okay. You want to rationalize the radical. So tell me what to do, Mercedes. Let me copy this and you tell me what's your first step. We want to rationalize 8 over the square root of 5. What's your first step, Mercedes?
It says to use the denominator to multiply the both side. So I would get that will equal 5 over 5.
What's my first step? What would I do? First step?
We're gonna use the denominator to rationalize all the both top and bottom, both numerator and denominator.
So what do I do? Tell me what to write.
You're going to write equal radical 5 over radical 5.
Okay, so where would I put that?
You put an equal and put it right there beside.
Would I put it equal?
Yes. I don't know, maybe I'm wrong.
No. What operation do I do here? What mathematical operation?
That would be division.
No.
Multiply?
Yes, you have to multiply.
Oh yes.
Now you're multiplying. You said radical 5 over radical 5. So you're multiplying numerator by radical 5 and denominator by radical 5. So let's just put it there.
That's exactly what I'm trying to say.
Yeah.
But I'm saying the wrong.
Yeah, but I want you to talk math to me, right?
Okay.
So you want to multiply by the numerator, radical 5, and the denominator, radical 5. Okay. So we're multiplying this. I'll just draw a line here. Okay. So let's see. So now, once you do that, I'll say this, what do you get for the numerator? What's 8 times radical 5?
That's 40.
You cannot multiply a number by
Oh,
radical. It has to
sorry.
be radical by radical, right?
Oh, sorry. The 5 radical
Let
5.
me put the asterisk there so you know you're multiplying both. So 8 times radical 5 equals what? Now say these.
Radical.
What does that equal to?
What do you call it again? 5. I can't remember what you call it.
What is 8 times radical 5?
5.
No. 8 times radical 5. Excuse me. 8 times radical 5 is what, Mercedes?
Equal to this what do you call it? Can just call it the radican 5.
No, 8 times radical 5 is just 8 times radical 5.
Oh, I'm thinking to the
Right?
oh boy.
It's just 8. You just put the coefficient 8 in front of the radical 5. That's it. Now, denominator, what's, and you were giving me that before when I was asking. So now, what's radical 5 times radical 5?
Now it's the radicand 5.
That's it. Very good. Okay. So you were giving me that before.
Yeah.
Now you got your answer. What's the answer, Mercedes?
The
A,
answer,
B, C, or D?
the answer B.
That's it. That's it. That's it. You got it. It's already simplified. So you just put answer B.
Oh,
That's it.
I just start to get the kick of that little part there.
Yeah, because most of the time, well, actually all the time, you can later simplify it. So when you multiply the radical in the numerator, whatever was there, you just say that multiplied by it. Now, sometimes you may have to simplify, but that's okay. Just always have whatever expression in the numerator times that radical. All right.
Okay.
And then in the denominator, radical times itself, just give radicand. That's the number under the radical. So that's 5. In this case, it's already simplified. So you just have what? B, 8 times radical 5 over 5.
Okay.
Got it?
Yes.
Okay, let me just put this here. Now, what do we call the 8? Let's talk math now. What is that 8 called? There's a name for it. What is it called? I'll say these.
Radicand.
No, the 8.
Oh, I don't quite remember.
Maureen, you know what the 8 is?
No.
Yes, you do. Starts with a C.
Or coefficient.
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 Right. Just like if this were a variable, say if this was y, 8y, 8 is a coefficient. 8 square root of 5, 8 is a coefficient. So that means I can add. If I had 8 times square root of 5 plus 2 times square root of 5, I could add the coefficients and get 10 times square root of 5. You got it?
Okay.
It's called the coefficient. All right. And you can add radicals when your coefficients are the same. You can subtract radicals when your coefficients are the same. Got it?
Yes.
Okay. Now let's go to simplifying. Maureen, simplifying. All right. Tell us how you did number 14.
I do. I find the square root of 48.
You found the square root. 48 has a square root?
Yeah.
I didn't know that 48 has a square root.
The square root of 48 is 16 and 3.
No, that's not a square root, Maureen.
Mm.
You mean you factored square root of 48 into 2 radicals, right? Yeah. Okay. And that's square root of 16. Put this here. Okay, back up here. Okay, so you factored square root of 48 into 2 radicals. So let's just put here, that's square root of 16 times what, Maureen?
3.
Right, times the square root of 3. So let's put our square root of 3. And that's our key there, Mercedes. We're trying to get these all with a coefficient in front of the square root of 3. Then we can add them, right?
Okay.
Let's see. Bring that back. Okay. Okay, so let's put the square root of 3 right here. Now, Mercedes, let me ask you, why did Maureen pick square root of 16 times square root of 3 as the factor of square root of 48? Why did she choose those factors?
Oh, just a second. 1 second. Let me go back here. Oh, wait a second. Let us shift the screen. Okay. It says why. Oops. Oh, I'm sorry. Because I think why did she choose 16, you say?
Why did she choose the factoring of square root of 48 to be square root of 16 times square root of 3? Why did she choose that?
Is this the perfect square root? Because 16 is a perfect square root for 48 and 3.
It's not a perfect square root of 48. Remember, we factor in radicals. We factor the square root of 48 into square root of 16 times square root of 3. Square root of 16 times square root of 3 give you square root of 48. And she chose the 16 3 because she already has a square root of 3 here. So she want to be able to add her square root of 3. So she wants coefficients in front of square root of 3. All right. Now, knowing that, I'll say these. Square root of 147 factors into what? Where you have a 3, a square root of 3. What would you put here?
I would put let me see, I would put what now? 49? No.
Would put what?
I'm thinking 40. I was saying 49.
49. Okay. And what's the other factor?
3.
3. Okay. So let's just take this and copy it. Okay, let's put that there. Okay, so 49, very good, because 49 has it's a perfect square root, right? Okay, now, so we have everything there that will have a coefficient of square root of 3. So I'll say these, what's the next step? Let me just copy that and you tell me what to write. Okay. Now, square root of 16 is what, Mercedes?
8.
8 times 8 is 64.
Oh, sorry. 4.
4, that's right. The number by itself that gives you 16, 4 squared. Okay, so that's 4. Square root of 49, Mercedes?
Should be 7.
7, very good. Okay, now you see all your coefficients in front of square root of 3. So, Mercedes, what would be the answer? Add the coefficients.
In 13.
13 and times what?
3.
You throwing away your square root?
Oh Lord, yeah, square root of 3.
Square root of 3. Big difference between 3 and square root of 3, right? Okay. 13 times the square root of 3. And that's your answer.
Okay.
Got it?
Yeah.
And remember I said when you're given expressions like this, you look at your smallest radical and think, what can I factor my other radicals in to get a 3? So you take the 48, say divided by 3, that's a 16, right? Take the 147 divided by 3, and that's your 49. Both of which are perfect square roots. 16 square root is 4. 49 square root is 7. Now you can add them. 2, 4, 7. 11 plus 2, 13. That's your answer. Maureen, number 15. You have that one correct, right?
Yeah.
Okay, so tell us how you did it.
Okay. I factored 80 square roots into 16 and 5.
Okay, so she took a square root of 80. Let's put that there. Okay. Let's see. Let me put that on the. Okay. Let me go to the next. Okay. So you factor that into, you said the square root of 16.
5.
Okay. Square root of 16, not 5. Square root of 5, Maureen.
Yeah. Yeah.
Okay.
This
Square root of
square root 5.
16 and square root of 5. So, Mercedes, you okay? Let's have Maureen factor that.
Okay, so yes.
Okay. So square root, because 16 times 5
It's
are factors of 80, right? So square root of 16 times square root of 5 would be square root of 80, right?
yeah.
Okay. So now, Mercedes, what's the next step?
Next step is
Okay, Maureen got you started. So what's your next step? What would you do next?
multiply the denominator with the numerator. I'm trying to see if I get it in my head again.
No. This is a product. Square root of 16 times square. That's not a fraction.
Divide.
No. The answer is jumping out at you. What is it, Mercedes?
The square root of 16 is 8. If it's 4.
That's right. So let's put a 4 here. And there's your answer.
And that's the answer.
That's the answer. 4 times the square root of 5.
Oh, first I get the square root of 80. And then still break it down.
You break it down into 2 radicals, and you think of a radical that has a perfect square root. So Maureen showed, since she know 80 is factored into 16 and 5, and 16 has a perfect square root. So she factored her 80 into square root of 16 and square root of 5.
Oh.
All right. And square root of 16 is a 4. So she's got 4 times square root of 5. Got it?
Yes, ma'am.
Okay. So now you know how to simplify radicals. You know how to change your scientific notation when you want to increase or decrease. All right. So now we want to look at what we call combinations. So let me go to share my screen. Any questions on any of the homework before I leave it?
Because can you just show down, let me look at what you just finished a while ago? Please.
Okay. The square root of 80.
Okay, that's it. You can go back now. Thank you.
Okay. Yeah, I just gave you one radical. So you want to find factors, just like if I give you numbers to find factors, I give you radicals that you can find radical factors, okay? So now let's go to a new share, and I want to look at combinations. What do you think of when you think of combinations? Anybody?
Like you're combining things together?
Yeah, combining things together. That's where combinations come from, combining. Now, how many have heard the term factorial? Ever heard of that term, factorial?
Yes, miss.
You have an idea what it is?
Yes, when things are factual, in other words.
What?
Like when things are factual, in other words, just called another way. You have
No,
fact, you
no,
have fact.
it's
Oh, the
not
mathematical way?
factoring. What did you say, Mercedes?
Are you meant the mathematical way?
No, when you hear the term factorial, what does it make you think of?
It made me think that I'm going to get some information which are true facts.
No. Maureen, you have an idea?
Not really, but I could say it on the screen.
Like something that is proven.
The thing here, factorial is of it. Factorial of a whole number n is defined as the product of that number with every whole number till. And then you get an example.
Yeah. Yeah, it's when you get the factorial of a number, you're really writing all the numbers you decrease by one, starting with that number and multiplied by all the numbers that follow it, each time decreasing by one until you get to one. All right. So factorial 4, you start with 4, say decrease by 1, 3, decrease by another 1, 2, another 1, 1. So factorial 4 will be 4 times 3 times 2
2
times
times
1,
1.
and that's equal to 24.
24.
Got it? Well, let me give you one. Okay.
So then it tells
Now,
you
now the
24.
factorial has the number and the the exclamation point. So if I gave you 10 factorial, based on what we said, the factorial meaning, Mercedes, what would 10 factorial be equal to?
25.
What?
25.
No, 10 factorial. I didn't say factors. There's a difference here.
I don't get it, miss. Why I'm trying to answer
Will be
that.
10 multiplied by 10.
What would it be, Maureen?
10 multiplied by 10.
No.
Oh.
You start with the 10 and you decrease by 1.
By 9. So what you want to is 9.
So it'll be 10
9
times 9
times
times 8 times 7,
times 6.
right?
4.
All the way up to 1.
3
Times 4 times 3
times 2 times 1.
2 times 1. That would be the factorial of 10. Okay. So each time you decrease your number by 1.
Oh,
Is that clear?
Yeah.
okay.
You just decrease your number by 1 until you get to the number 1. All right, so 10 factorial will be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. All right, 3 factorial. What would that be equal to, Mercedes?
1, 3 factorial 4. Let me see.
Start with the 3, decrease by 1 each time. So what would that be equal to?
Oh, this is 3 times 1 times 2.
They have to be in order. I say decrease by 1 each time. What comes after the 3?
2.
2. And what comes after the 2?
1.
1. And what's that equal to?
Equal to, give me,
3 times 2 times 1 equal what?
I took multiply up that. I didn't know.
Yeah, that's multiplication. 3 times 2 times 1. What is that equal to, Mercedes?
3, 2, 1, 6.
6, that's right. So factorial 3 is equal to 6.
So this factorial means that you got to decrease all the time. Not in,
Yes, you
oh,
just
so you can
decrease by one
decrease by
until
1.
you get to one.
Uh,
All right, until you get to the number one. Okay. So if you had 100 factorial, that would be 100 times 99 times 98 all the way up to one.
okay, so it could only be decrease. It can't increase, right?
No, only
Right.
decrease.
Okay.
That's right,
Okay.
Maureen. You can
Okay.
only decrease.
Decrease. Okay.
Okay, so I want you to understand factorial because we use that in our formulas for
Okay.
combination, and then we get the permutations. We have a permutation formula that also use factorials.
Okay, I got it right in my book.
You got it? Now, let me just give you the formula for combinations. Now, combinations, here's the formula. We have a number of items and we have the number of items selected. So I'll use this convention. I'll put the C for combination. I'll put the number of items, comma, and the number of items selected. In other words, you could have 10 items, you want to select 5, right? So that would be 10, 5. Sometimes it's written with a subscript or superscript, but I'll stay with the parentheses. Combination, in the parentheses, number of items, that's like a total, and number of items selected. Now, to solve that, you take the number of items factorial divided by the number of items minus the number selected factorial, and then the number selected factorial. All right. Now, sometimes you don't have to use this. You can use a simpler method, and I'll show you how you can use a simpler method. Now, if you were making, say, if you went to an ice cream store, you had 35 flavors, 10 different toppings, and 2 containers. How many different combinations do you have to choose from? Now, you could use this formula and solve that, but you can also multiply the number of flavors times the number of toppings. This will be 35 times 10 times 2, 350 times 2. That means there are 700 ice cream combinations. Got it?
700 ice cream. I don't understand that part.
Well, there's 35 flavors right here. You see that? 10 different toppings. Okay, I underline that. 2 containers. You can have a dish or a cone, right? 2 different containers. Okay. Now, the different combinations would be the product of the flavors and the toppings and the containers. That's flavors 35 times 10 for the toppings times 2 for the containers. 700 ice cream combinations when you have 35 flavors, 10 different toppings, and 2 containers. And that means when people are buying, say, like ice cream in the store, they pretty much know the flavor they want, right? They may not know the topping because the topping might be dependent upon what topping is being offered at the store, but they generally know if they want a dish or a cone, right? Mercedes, did that explain that to you?
Not so straight, but instead of getting it.
No, I'm just showing you how a simplified way of doing combinations without using a formula. Now, we'll use a formula, but I want you to know that you can also multiply out your various choices here. 35 flavors, 10 toppings, 2 containers. So if you had a question, since how many ice cream combinations are there? 35 times 10 times 2 gives you 700.
Okay.
All right, Mercedes, you have a question?
Maybe next time you do something like this, I'll start to get it. I start to get a little understanding, but go through something like this again. I think I'll get it. Cause I'm
But
looking at the combination formula you have there.
yeah, but I'm saying I'm doing this. You could do it with the formula, but I'm showing you a simplified way of doing some problems. Now, when you saying that you want to find a certain number within the set, then we couldn't use this, right? If we said a certain number of items within the set. But here I'm just saying, how many different combinations can you have
Oh,
given 35 flavors, 10 different toppings, 2 containers? You could have 700 different
different
ice cream
combination.
combinations.
Okay.
Now, I want you to use the same thing on number 2. Frank is making a sandwich. He'll have one type of bread, one type of meat, one type of condiment. Okay, so there are 4 types of bread, right? There's 3 kinds of chicken. Let's put the, I'm sorry, 3 kinds of meat, chicken, turkey, and roast beef. And you have how many condiments? You have 4 different condiments. So using just what I did on the ice cream, okay, how many ways can Frank make his sandwich? Somebody want to tell me?
See,
I get back to you in a minute, Barbara.
Okay,
you have chicken, turkey, beef.
so the combination,
You have horseradish. You have mayo.
so that would be equal to what, Mercedes? What would you say it would be?
Chicken. You could have up to every continent.
How many ways can he make his sandwich? Let's just do it by without the formula now, because you could do the formula, but the formula you would have to do the meat, then the bread, and then the
The meat is
condiments, and then add them together. But I want you to do it just like I did with the ice cream. So how many types of bread are there, Mercedes?
so you have 4 different types of bread,
Okay, 4. How many types of meat?
3 different types.
Right. How many condiments?
Um, um, 1 type.
How many condiments are there he can choose from?
Oh, let me call it. 1, 2, 3, 4.
Okay. Now, what is that equal to, Mercedes? 4
4, 4,
times 3 times 4.
4, 4 is 16, and 16 times 3, you're gonna get 48.
That's right. So he could have
I'm
40.
back, Miss Barbara.
Okay.
Sorry to
So,
talk to Mikey, so I have to lift you.
okay, no problem. Okay, this with the sandwich, how many ways can he make a sandwich? 48. Be the number of types of bread, 4, times the number of types of meat, 3. For them,
Yeah.
3 is 12, times the condiments, 4, and that gives you 48.
Uh-huh.
So I'm just showing you a way you could do these kind of problems without going through the combination formula. Now, some of them you'll have to use the combination formula, and we'll look at some of those. But if you use the combination formula, you would have to say the bread separate, the meat, the condiments, and then add them together. And then you'll still get 48. It's just that it would take longer. But actually you would only do the condiments and the meat and the bread, because they both 4. So you get the same for the bread and the condiments because they both 4, right?
Okay.
Got it? So this is similar to the one we did here. But I want to take,
I think we do some of these already with you and I'm just bad.
yeah, we have done some of these already. You're right. You're right. And you'll see when you start doing them, you said, okay, we've done some of those. It's like, think of, you go to a restaurant and they have 3 different entrees, right? They have 4 different soups. They have 5 different salads. They have 3 different desserts. And you want to find how many ways can you order from the menu where you have 1 entree, 1 soup, 1 salad, and 1 dessert. Same thing. You've seen those kind of problems, right, Mercedes?
Yes, yes, Miss Brown.
Yeah, have you seen them? You too, Maureen, right?
Yeah.
Okay, so those, when you see those kind of problems and they don't give you any kind of restrictions on what you must do with them, you can just multiply them out, just like I did here. But now, if you had one like, let me just go to, okay. Now, like number 3, how many ways are there to choose a team of 3 from a group of 10? Now this one, you would have to use your combination formula, right? So you'll select in 3 from a set that has 10.
Where's the reading, Miss? Let's see.
I'm on the other side.
Oh, oh.
You see number 3? How many ways are there to choose a team of 3 from a group of 10? Now here you would use your combination formula.
They say R equals 3.
That's right, R is 3. That's what you selected. The whole group is 10.
And N equals 10.
So N equals 10, okay? Now, let's go to our formula. N is 10. What was selected is 3. N factorial will be 10 factorial. R factorial will be 3. Then I take the difference of 10 minus 3, 10 being my total, and 3 what I'm selected, and that's also a factorial, right?
Okay.
So notice I have now 10 factorial. What's 10 minus 3?
Is that 7?
So that's 7. So that would be 7 factorial. Now when you expand these out, 10 factorial, I expand it all out all the way out to 1, right? And then 3 factorial is 3 times 2 times 1. 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. Now, when you have these factorials like this, you can cancel out the ones that are like in the numerator and the denominator. So, Mercedes, when you look at your numerator and denominator, what of the factors you see the same in numerator and denominator?
Where are we again?
Right here.
Oh. Yeah. So the question was,
What factors do you see the same in both the numerator and the denominator?
okay,
It's not.
see factors of 2.
What do you see?
You're asking me to see what's the same factor top and bottom, right?
Right, yes. So just tell me what they are.
Okay, what I see is 7,
Okay.
6, 5, 4, 3, 2, 1.
Yes, so these are the same. So let me just make this bigger. Okay, so those are the same. Let's see. That, okay, and then down here at the bottom, those are the same, right? Let me just make that bigger. So you know you could just cancel those out. I'm not canceling them out, I'm just making them bigger.
Okay.
All right, so these cancel out. All right, now What do I have left after I cancel these out? What do I have left at the top? I'll say these.
Copy of 10 by 9 by 8.
That's right. I have these left. And what do I have at the bottom?
At the bottom, you have 3 by 2 by 1.
That's right. So now I can multiply them out. 10 times 9 times 8. 90 times 8 is 720. 3 times 2 times 1 is 6. 720 divided by 6 is 120. So how many ways are there to choose a team of 3 from a group of 10? 120.
So, Miss, you multiply to level, you multiply straight across the top and straight across at the bottom.
What was the question?
How do you multiply? Straight across in the top and straight across at the bottom? Oh,
Yeah,
yes,
just
yes.
3 times 2 times 1.
I saw it now, I saw it.
Yeah, 3 times 2 is 6 times 1. 3 times 2 is 6 times 1 is 6. And straight across here, 10 times 9 times 8 is 720. These come out right here because they're the same. Now, you didn't have to expand them out, right? Because if I have a 7 factorial here, right? And I have a 10 here, that means anything 7 and after I could take out. You follow?
Say that again, that little last
Okay,
part.
you see this says 10 factorial, this says 7 factorial, right?
Yeah.
I don't really have to expand these all out. I know 10 goes all the way up to 1. So that means 7 and after I can take out the 10 right here, be left with 10, 9, 8. I don't have to expand them out to know that, right? Because even 7 factorial, 7 times 6 times 5 times 4 times 3 times 2 times 1. And the 10 factorial also has 7 times 6 times 5 times 4 times 3 times 2 times 1, right?
Okay.
So I expanded it out here just for simplification, but you don't have to do that. If you have a 10 factorial here in the numerator and a 7 factorial here in the denominator, you can just say, well, okay, I have 10, 9, and 8 left, so I don't need the 7. So you can just cancel out the 7 here, cancel out the 7 factorial here, and you're left with just 10, 9, and 8.
It was so ridiculous.
You got it?
Yes.
Maureen?
Yeah, Mr. Yeah.
Go to mute. Go to mute when you're talking to people.
No, I'm not talking to her. She just passed. They got the door open because the little heart in here.
Oh, okay.
Yeah.
So you follow what I just said, Mercedes?
Yeah.
I'm trying, miss. I'm trying, but I'm getting it.
No, I'm saying that, Maureen, you understood what I just said?
Yeah.
Okay, repeat what I said, Maureen. You said you understood. What did I just say about 10 factorial and 7 factorial?
Oh, you were saying 10 factorial because you said you could multiply all those numbers, right? But you take out the matching numbers, right? Which is 7 multiplied by 6 multiplied by 5 down to that.
Right. Yeah, but I'm saying
Yeah.
I expanded them out here. That's the long way,
Right.
but I'm saying you didn't have to do that.
Right.
If you had 10 factorial, and that's divided by 3 factorial, 7 factorial,
Yeah.
you can cancel out the 7, and the 7 factorial that's within the 10, you can cancel that out, and you just have 10 times 9 times 8.
Yeah.
Got it?
Yeah.
Mercedes, you with me?
Yes, ma'am.
Okay, so I'm saying when you really understand your factorials, you don't have to do it the long way. If you see duplicates, you can just cancel them out. 7 factorial will cancel out the 7 this within the 10 factorial. And what you're left with, 10, 9, and 8. Got it?
Yeah.
Okay, now let's go to number 4. And this is also using the combination formula. 5 people in a club. 3 are going to be on the planning committee. Determine how many different ways this committee can be created. Same formula. What is N, Mercedes?
N would be the 5 people.
That's right, the 5. And what is R?
R would be the 3.
Yeah, the 3 that's going to be on the committee, right? So
Yes.
you know what your N is, a 5. You know your R is a
It is
3.
3.
So just plug it in the formula. 5 total, 3 selected. All right, 5 factorial. 5 minus 3 is 2 factorial. Now, like I said, you didn't have to expand them out, but I did it again. 5 factorial, 5 times 4 times 3 times 2 times 1, 3 factorial, 3 times 2 times 1, 2 factorial, 2 times 1. What is in common, Mercedes, numerator and denominator?
Okay, we have in common 3, 3, 2, 1. Well, let me see good. 1 minute. I'm picking from the last one or the first one.
Okay, so what do you have in common here?
Up there, I have in common 2. Let me start at 1, 2, 3.
Well,
That's
you have 3, 2, 1, 3, 2, 1. So really what you have left is, okay,
Five.
let me just take this up. You really just have 5, 4. I mean, this same, you get the same answer. Okay, so you have 5, 4, right? Because 3, 2, 1, you see that, that's the same in both, right? Top and bottom. 3, 2, 1, there we go. All right.
Okay.
Okay, so I have 3, 2, 1, I have 5, 4, and I have 2, 1. So this would just be 2 times 1. All right, and 5 times 4 is what? 20. You see, there's more than one way of doing it. 20, and 20 divided by 2 is 10, right? Let's see, on the line, and put the 2 here. And 20 over 2, or half of 20 is 10. So we answer the question, how many different ways can this committee be formed? 10 different ways. Got it?
Yes.
Is it clear using the combination formula?
Yes, it's getting clearer.
It's getting clearer? Okay. All right, let's look at, okay, let's look at another one. We have 5 new employees from a list of 10 applicants. How many ways can we select the 5 new employees from the 10 applicants? The 10 is the total, right? 5 is what we're selecting. So 10, combination 10, 5, 10 factorial over 5 factorial over difference in the total and what's selected. 10 minus 5 is 5. So we have 5 times 5 factorial. Here I expanded it again. Take out the ones that are the same. Which ones are the same? Numerator, denominator.
Where are we? Where did I miss you? Okay.
Right here. Which ones are the same, Mercedes?
Ones that are the same, we start with 1, 2, 3, 4, 5.
Right, those are the same. So let me just make it bigger. Okay. And you have 5 times 4 times 3 times 2 times 1. That's the same, right? So let's just take that out and just make that bigger. Okay, so what do we have left, Mercedes? Once I take that out, what do I have left? These 2 are going to cancel out. So what's left on the top?
At top you have 10 times 10 by 9 by 8 by 7 by 6.
Right, and what do I have on the bottom?
5 by 4 by 3 by 2 by 1.
So when you multiply these out, you can do these on your calculator, and You have 30,240 over 120. So there are 252 ways we can select 5 new employees from a list of 10 applicants. Got
So
it?
when we get like that, we simplify it by dividing the numerator by the denominator.
Yeah, you simplify by taking your factorial. Well, like here, I said 10 over 5, right? You could take the 5 out of here, and that just give you 10 by 9 by 8 by 7 by 6, and just take that 5 out. So you could just cancel out this 5, cancel out the 5 that goes with the 10, and that just give you 10 by 9 by 8 by 7 by 6. And then you still have this 5 factorial, which is 5 times 4 times 3 times 2 times 1. Got it?
Oh, yes, thank you.
So you can simplify it without expanding it, because 5 factorial is part of 10, right? 10 goes all the way up to 1. 5 goes all the way up to 1. So you could just really stop the 10 at 6 and just cancel out this 5. But you still have this 5 factorial that you have to expand. Got it?
Yes.
Questions?
Go back there, Miss Barbara.
Yes.
Then I still have this. What?
You still have this. See the 5 factorial there?
Yes.
You have 5 factorial times 5 factorial. One of them cancels out with the 5 factorial that's within the 10, but the other one remains. See? Because I have a 5 factorial times 5. I can't cancel out both of them, right? Because I don't have 2 sets in the top. I can only cancel out one set of the 5 factorial. Got it?
Okay.
Questions?
Just thinking.
Okay, now we just went over the formula, and let's see if you remember it. Okay. All right. What's the combination formula? A, B, C, or D? I'll say these. Which one?
The formula is C.
C. Very good. You remember. Nice. Those are the kind of questions you'll get, right? Make sure you know the formula, and then give you problems or you have to use the formula. Okay, so that's answer C. All right, now actually I put the answer there, but that's okay. Okay, so I want you to solve number 2.
Number 2.
10 basketball players, a 5-member team, and a captain. See if you can solve that one. That's like a 2-step problem. See if you can solve it. I would use the combination formula. You have 10 basketball players. That's your total, right? And you want to select a 5-member team.
Yeah.
Remember, you selecting 2 things here, and you're selecting a captain. So let me give you a hint here. Once you select your 5-member team, okay, then you want to select a captain. So what would be your first combination formula?
10 basket players and 5-member team and a captain. So
What would be your first combination formula? Okay, we have what? C.
C and
Well, we have the C10-5 right here, right?
Yeah.
We have it right here.
Yeah.
Okay.
C
Okay, so
5-member team.
and 5.
okay, so you want to select your 5 players. So do that one first. Tell me what you get.
So I'm
Solve
going
that one.
to 10 times 9 times 8 times 7 times 6 times 5 times
10 times 9.
times 3 times 2 times 1. And then the 5 times 4 times 3 2 times 1. So you're gonna pick out those that are
Is it like
Now,
10
now,
times 9?
now this would not be a 5, and why? Because if you got 5-member team and a captain, this will be a
That'd be
6.
6.
That's right. This will be a 6. So this will be a 6
that's 6, miss.
because you have 5-member team and a
Captain.
captain. 5
Oh,
plus 1 is 6, right?
oh, I didn't know I could combine that.
Yes, because 5-member team and a captain means you're selecting 6 players. From that 6, you're going to take a captain. Okay, so I want you to solve that first, right? So C total 10, selecting 6, 10 factorial over 6, and 10 minus 6 is 4, right?
Or, yeah.
Okay. So you got 10
Minus 6. Equals to 4.
Okay, let's see. Use my calculator.
Oh,
Times 9 times 8.
so 3 is out, 2 is 1 is out, 4 is out. 5 is out. 6 is out.
Okay, 10.
7 is out.
Anybody got an answer on that one?
1
What
second.
did you get?
Not yet, miss. I'm working it out.
Okay.
6 minus 10 is 4. So then it'd be 10.
I want to know what answer you got here. Okay, C 10 and select 6. Okay, someone got an answer for me?
I don't know if I'm doing it wrong, miss.
Now 10 minus 6 is 4, right?
Yeah.
But that you have a 6 factorial here. You can take that out of the 10. So that's going to be 10 times 9
5 times.
times 8 times 7, right?
That, yeah,
Get that for
yes,
10 times 9 times 8
times
times 7. Okay, because the 6 factorial will come out of the 10. I mean, the 10 minus 6 is 4. The 6 factorial here will come out of the 10. Now you have the 4 factorial. 10 minus 6 is 4. So this will be 4 times 3 times 2. So let's just put that here. And that was 10 minus 6 is 4 factorial. So this will be 4 times 3 times 2. 4 times 3 times 2 times 1.
I don't really get the part.
Okay. 6 factorial, Mercedes, will come out of this 10. So what's left is 10, 9, 8, 7. 10 times 9 times 8 times 7.
Yes,
But I still have my 4 factorial, which is the difference in 10 and 6. So that's 4 times 3 times 2 times 1. You
oh,
follow?
So the answer would be 3 is 12. 12, 2 is 24.
So what's the answer?
1 sec. 1 sec.
What do you get for the
It's
numerator?
24.
No, 10 times 9 times 8 times 7. What's that equal to?
And you're okay, that's 5040.
Okay, 5040, that's correct. 5040. And what do you get for the denominator? 4 times 3 times 2.
2. I get 24.
24. Now divide that out. What do you get?
I get 210.
210. Okay. So, and that's correct. So you got that part correct. That's the 6 out of the, okay, let me make that bigger. Okay. Okay. So that's 4. There's a 4 times 3 times 2. Okay. Let's see. Right. So you got 210. Maureen, you got that? 210? Let me just put that here and put equal to 10. So that's the selections with the 6 out of the 10, right? And there we go, the 210. But now we have a captain, right?
A captain. So now we need a captain.
Yeah, now we've got to select a captain, but the captain can be selected from the 6 players in 6 ways. So you just really multiply it. This should have been 1260. Sorry. Yeah. So this, okay.
So the 1260.
6 members can be selected, 10 players. But if you have a captain, then you multiply the 6 by the 210 and you get 1260. Yeah. So that would be your answer. Okay.
Say it again.
Yeah. 210 and you have a captain to select from this 210. So you just multiply 6 times 210 and that would give you the answer of selecting the 5-member team and a captain. So you remember we selected a 6, but we have a captain has to come from that, right? So we just multiply 6 times the 210 and there's our answer would be A.
I'm sorry.
And the other way, you could take the 5 out of the 10, we get the 252, right?
All right.
And then just multiply the 5 times the 252 and you still get 1260. So there are different ways to do it. All right. You can do it like, yeah, the other way is to take the 5 out of the 10, and that's the 252, like we got on that other problem was 5 out of 10. And then with the 5, then we have 5 ways of getting the captain. So it'd just be 5 times the 252, and that way we would get the same answer, 1260.
So you use.
So all I'm saying is you could do the 10-6 way, get the 210, multiply it by 6, 1260, or you could use the 5-10 way and then multiply your result by 5 and you still get 1260. So there are 2 ways you could do it. You could do the 5 or you could use the 6. 6 total, 5 without the captain, and then multiply that by 5 and that would give you the answer, same answer.
Okay.
Questions?
I will review this, miss. I get most of it, but guess what? I'm sure I'm so tired.
Yeah, I can understand that. All I'm saying, Mercedes, is that
Does-
you could use the 5 out of 10, or you could use the 6 out of 10. But once you get the answer, you've got to multiply. If you use the 5, you multiply your answer by 5. If you get the 6, you multiply if you use a 6-member team, you multiply your answer by 6. Either way, you'll get answer B.
Okay.
All right. Well,
So
I'm sorry, answer A, 1260.
why 1260? That's a captain.
Why what?
Remember, we're trying to get a captain. Oh, I don't understand that part.
What was the question, Mercedes?
Yeah, we're trying to get a captain also.
How many different selections can be made if you're selecting from 10 players, a 5-member team, and a captain?
Oh, got you.
You got it? So how many different selections can be made if you're selecting 6 players and one of the 6 players is a captain? So all I'm saying is you could use the 10, 6, that 6 includes the captain, right? And once you get that number, you multiply it by 6. Or you could use 10, 5. And once you get that combination, you multiply by 5 and you get the same answer. You got it?
Yeah.
Any other questions? Maureen, you okay?
Yeah.
All right. All right. So we're going to stop here. And I think you'll be able to do some of these combinations. You think you're ready to do a one or
Right,
two?
Sam.
I could try.
Yeah. Okay. Let's see. All right. So we'll stop here. I'll just give you some you can do without the combination formula and some you can do with the combination formula.
Uh-huh.
Like the ones like with the menu, I think you'll be able to do the menu one. Like if I gave you so many entrees and salads and soups and desserts and beverages, you could find that, right? That one, those kind you can do without the formula. But if I send you selecting a number out of a total, then you would use your combination formula. All right.
Okay.
Okay, so we will stop here.
Okay. Have a nice weekend.
Okay, let me
Okay. I'll talk to you when you take off record.